Try this next example, example number whatever it may be. Example number 6. Okay. So example number 6, and given the question is over here, consider there is a fixed pulley. On this fixed pulley there is a mass, and this mass, let's say 10 kg, and over here is one more block, and consider this one is your 20 kg. Over here is one spring, and with the spring one 10 kg is been attached, and over here let's say this one is been tied. Okay. Initially, given condition, system is at equilibrium. System is at what? Rest. That means block A, block B, initial velocities, accelerations all are 0. Okay. Now the question is, question number 1 in that, find out the tension in each string. Let's say this one is your spring 1, this is your string 2, and over here is what? S3. Okay. T1 will be the value here. So T1 is the tension over here, T2 is the tension over here, and T3 is the tension here. First question is, find out the tension T1, T2 and T3. Orally bata do bhai, jaldi batao. What will be the mg of this one? 100 Newton. Okay. So 100 will be acting in the downward direction. Over here again 100 Newton. 100 Newton is also acting in this direction. Mg of this one will be acting in the downward direction. That is what? 200 Newton. Can I? Okay. So over here becomes 300 Newton. Jaldi bolo. 300 again over here because it is being tied to a fixed pulley. Okay. Then over here 100 Newton is acting in the downward direction because of the mg, and again now the tension, that is what? T3. What will be the equation to balance this one? System is at equilibrium. So for the system at the equilibrium, that means the amount of forces acting in the downward direction and upward direction should be equal. Okay. So T3 plus of 100, that is nothing but your 300, or T3 value becomes what? 200 Newton. So T3 over here. So these are the situation before cutting. We are not cutting yet. Neither we are cutting a spring, neither we are cutting any string. Okay. So before cutting, and the value, that is what? T1 is equals to 100. Please help me. T2 is equals to how much? 300. Okay. And T3? 200. Okay. So T1, T2 and T3, that is what? 100 Newton, 300 Newton as well as 200 Newton in each string. Okay. This is the basic calculations. Now the question arises, if I cut this one, if I cut what? S2. If I cut what? S2, now the question is, find out the tension, that is T1, T2 and T3. Okay. As well as the acceleration of block A. Let's say this one is your A, this one is your B, and this one is your C. Find out the acceleration of each block and the new tension after cutting. That is the question. Okay. Come on. Tell me the acceleration as well as the after cutting tensions. Okay. Come on. Everyone got the answer? Okay. And tell me the values now. T1 is equals to how much? 100 Newton. Okay. And T2? T2 0. T3? 0. Okay. 200. Beta 200 क्यों हो गई है? You are telling this T3 is equals to 200. Why this 200 you got? Because of you got 300 earlier. This 300 becomes 0. If this 300 becomes 0, do the system remains at equilibrium? Obviously no. This one will be going in the downward direction. Once it start to go in the downward direction, tension in this one becomes what? 0. Okay. After cutting, it becomes 0. So T1 is equals to 100, T2 is equals to 0, and T3 also becomes what? 0. Okay. Now the acceleration. Acceleration of A. Obviously acceleration of A without any calculation we can say 0. So acceleration of A, F net is equals to 0. 100 Newton is acting in the downward direction, 100 Newton is acting in the upward direction. We are not doing anything, we are not cutting this spring. So tension in this spring remains as it is. That is what? F net on this block A is 0. So acceleration of this one becomes what? 0. Now acceleration of B. Acceleration of B, now tell me, this one will be going in the upward direction, downward direction. Obviously no force is acting in the upward direction. T2 becomes 0. Obviously this one will be going in the downward direction. This 200 remains as it is. That is what? Because of mg. This 100 remains as it is because we are not changing anything or cutting this spring. Are yes or no? So for acceleration of B, or for block B, what will be the F net? 200 plus of this 100, 300. So 300 will be the force, and what is the mass? That is what? 20. Acceleration of B is nothing but 15 meter per square second. Yes? Okay, very good. And tell me the acceleration of this one. What are the forces acting? This T2 becomes 0. Sorry, T3 becomes 0. And any other force is acting? No. That is what? Only mg is acting, that is in downward direction. What is the mass? That is what? For block C, I can be writing that 100 upon 10, that is acceleration of C, that is nothing but 10 meter per square second. So everyone got these answers. Okay. Now the question is, same diagram, same condition is given. If the system is at rest or the equilibrium, what happens if I cut S3? If I cut S3, what will be the new tension in each string? That means S1, S2 and S3. Obviously S3 becomes 0. Yes or no? Now you need to calculate T1 and T2. Acceleration of each block, that is block A, block B and block C. Tell me the acceleration keeping the same diagram. Okay, come on, try this. Okay, let me check your answer. Shall I? Okay, now here is the fixed pulley. On this fixed pulley there is mass. One more spring is been connected. क्या हो गया? अरे कुछ नहीं होगा, इधर लगा दो उसको. Over here this one is fixed. Nothing will be happen. Okay, tell me the masses of this one. 10 kg. This one is how much? 20 kg. This one is how much? 10 kg. किसको कटे रे? इसको कटे ना? Okay, if this one is been cut. Okay, now tell me the values over here. 100 Newton is acting in the downward direction. Over here 100 Newton. Can I say that? Still, even though before condition remains same. Okay, so 100 Newton is acting over here. 200 because of the mg. 300 will be acting over here. 300 will be acting over here. 100 will be acting over here plus of 200. That is what? Tension. So this is the before cutting situation. Now after cutting situation we need. Okay. So tell me the values. This one is what? T3. Okay. So this one is your T3. This one is your T2. This one is your T1. Still T1 remains unchanged. Can I say that? Okay. So T1 still is how much? 100 Newton. So no change in the spring. We are not cutting again the spring. Okay. If we cut the spring, tension becomes over there 0. But acceleration of again B and C. Which one is B? Which one is C? This one is your A. This one is your B. This one is your C. Okay. Now T2. T2 after cutting it will remain 300 or it will change the value. Let's say T2 is nothing but T. T liya? Okay. So T2 is equals to now T. After cutting this one, either this one will be going in the upward direction or either this one will be coming in the downward direction. By seeing this one is a heavier mass, we can consider this one is going in the upward direction with the acceleration A. Block B is going in the same direction, opposite direction in the downward direction by acceleration A. Why? Because pulley is what? Fixed. Okay, now T2. We don't know. So T2 we need to calculate, and T3. T3 becomes what? 0. Okay. Now how can we can? Yes, very good. FBD laga do ispe. So block B and block C FBD. So for block B we can write the equation. How much is the acting in the downward direction? 300. So for block B 300 is acting in the downward direction. T is acting in the upward direction. Now this T changes na. So this we don't know this now. Okay na. So T is acting over here, and which is equals to how much is the mass? 20A. 20A, consider this as your equation 1. And on block C, tell me the equation. It is going in the upward direction. T will be greater. Okay. So T minus of 100 to bad jao hallu bolo, and NA. This is your equation number 2. Adding equation 1 and 2. Okay now. So this T and this T get cancelled. Left out is what? How much? 200. That is equals to 30A, or acceleration is nothing but 20 upon 3 meter per square second. Can I write like this? Okay. Substituting the value in any equation, I will be getting what? T2. This is nothing but, this T is nothing but T2 na. Yes? Okay. Substituting the acceleration in any equation, I will be getting what? Tension value. So T is nothing but 10 into 20 upon 3 plus of this 100. Okay. and this becomes 500 upon 3 and 500 upon 3 newtons. Those who have got this one, correct answers. Okay, we can cut this one also. We can cut this one also, and we can frame the question multiple pulley systems. One pulley is in motion, one pulley is at rest, and all you need to calculate if one string is being cut. Okay, we know 3 different types of the what? Pulley systems. Yes or no? Acceleration of pulley is nothing but AA plus AB by 2. Are yes or no? Okay, so if the pulley is in motion, we need to apply that. If there is a single long string method, we can apply the third pulley. Are yes or no? So we can find, if we know the constraint, we can find the acceleration. Once we find the acceleration, we can find the tension. Yes or no? Okay. N number of questions can be framed over here. I got my point. Or time pass karunga aise questions pe. Okay, shall we move to the next one? Okay, right now. Okay, shall I proceed now? एक और कर लो. Example number what? 7. Okay. Now listen to me. Shall I? Okay. So here is a wedge, and over here 37 degree, and over here is what? 53 degree. Okay, there is a wedge, and on this wedge there is a fixed pulley, and this fixed pulley is being connected with one mass. Let's say this one is having a mass 5 kg. Okay, and this one is being connected with one more mass. Again, this mass is again 5 kg, and this mass is being connected with one more pulley, and this pulley is being again connected to a fixed pulley. There is one more mass over here. This mass is what? 10 kg, and let's say there is a spring over here. This one is being tied on a fixed pulley. Okay, 3 masses. Initially, system is in motion, and all blocks are moving in that direction. Consider all blocks are moving in that direction. Okay, this time system is not at the equilibrium. System is in motion. Okay, all blocks are in motion except this wedge. Wedge is at rest. Okay, so now you need to calculate. Find out the acceleration of each block. Let's say this one is your block A, this one is your block B, and this one is your block C. Before starting, please help me. If first thing, this one is a fixed pulley. Are yes or no? If this one is a fixed pulley, 5 kg, and that 5 kg will be accelerating in that direction, then can I say this one and that one will be, both A and B will be accelerating with same velocity? Are yes or no? If I mark the values of the tension over here, let's say T1 is acting in this direction. Obviously T1 over here, and how much? To T1. Are yes or no? Okay. Similarly, if I want to mark over here the tension, that is what? T2 over here and T2 over here. Okay. Let's say this one is accelerating in this direction by A1 acceleration. Obviously, this one will be accelerating in this direction by A2. This one will be accelerating in this direction by A2. Yes, because A and B both are being tied to a fixed pulley. Okay. Question is, find A1, A2, T1 and T2. Find. Question number 1. Find A1, A2, T1 and T2. Come on. Try karo. आगे सभी का आंसर. Everyone got the values? Okay, now over here 50 Newton will be acting 50, and this is nothing but 4 by 5. That means this one is 40 Newton over here, and over here will be 10, 100, 3 by 5. That is what? 60 Newton is acting in that direction. Okay, so for the block A, tell me the FBD of this one equation. So it is accelerating in that direction. So T2 will be greater. So T2 minus of this 40 Newton, which is equals to 5 times of A2. And for block B equation, 2T1, okay. So 2T1 minus of T2, that is nothing but 5A2. This is your equation 2. And for the block C, that is what? 60 Newton. 60 Newton minus of T1, that is nothing but 10 of A1. ये तो सबको आ गया equation. Now what to do? This is your equation 1, this is your equation 2, this is your equation 3. Okay, सबका यहाँ तक तो आया. Okay, how many of you tried constraint? हाँ, Okay, हाँ कितना है? Okay, let me check that value. A is equals to A1 is equals to 2A2. Okay, चलो देखते हैं. Okay, this one is a single string. Can I say that? Can I say that? Okay, so this is your point number 1, point number 2, point number 3. This is your point 4. This is your point 5, and this is your 6. Okay, now. So how many points are there? A1, A2, A3, A1 is equals to so on till A6, which is equals to what? 0. Now tell me, with respect to wedge. With respect to wedge, if I calculate with respect to what this wedge, that means this wedge is at rest. Are yes or no? If this wedge is at rest, that means obviously this pulley is at rest. Yes, that means how many points are there? That is what 1, 4 and 5 will be equal to 0. Okay, how many points are connected on this 5? 5 is going in that direction by what? Acceleration, that is A2. So A1 is 0 and A2 will be, if it is going in that direction, obviously this length decreases. Are yes or no? If this length decreases, that means minus of A2, minus of A2, plus of 0, plus of 0, and this one is plus of A1, which is equals to 0. Can I? A1, it is going in the downward direction, obviously length increases. If length increases means positive. So yes, your equation is correct. So A1 is nothing but 2 times of A2. Okay, यहाँ तक आ गया सभी का, सभी लोग का आ गया यहाँ तक. Okay, now listen to me. Take T2 from here. Okay, then T2 becomes what? 40 plus of 5A2. Are yes or no? Similarly, take T1 from here, and T1 becomes what? 60 minus of 10A1. Are yes or no? And this 10A1 can be written as 2 times of A2. Are yes or no? Substitute T1 and T2 in this second equation. You will be getting what? A2. After A2, substitute in any equation, you will be getting what? A1 also. I got my point. Similarly, you will be getting T1 and T2. Come on, try this. Okay, everyone got the answer? 28 and 48. Let me check over your values. So, shall I? Okay, now, so from here, T1 can be, इसी में लिख देता हूँ directly. So, substituting in second equation, that is what T2 T1 minus of T2 is equals to 5A2. Are yes or no? And T1 is how much? T1 is nothing but 60 minus of 10A1, that is what? 20A2. So, 2 into 60 minus of 20A2 minus of 40 plus of 5A2, which is equals to 5A2. यही है सभी को. Okay, now solving this becomes what? 120 minus of 40A2, then minus of 40 minus of 5A2, which is equals to 5A2. ये कितना है रे? 8. Okay, देखते हैं 8 by 3. Okay, now so 120 minus of this 40, 80 and that becomes what? 50. Okay, so yes, so 80 is equals to how much? 50A2, or A2 is equals to what? 8 upon 5 आ रहा है, 3 के कोई 8 upon 5. Okay, sorry. So my mistake रहा. So A2 is equals to what? 8 upon 5 meter per square second. Similarly, substituting the value of acceleration, that is A2, in any equation, you will be getting what? T2. इसको T2 निकालो. So let us calculate what? A2. If A2 is what? 8 by 5. Obviously, A1 is twice of this. That means 16 upon 5 meter per square second. Okay. So A1 we got 16 upon 5. And A2 is equals to 8 upon 5. Now substituting A1 and A2 in those equations, you will be getting what? T1 and T2. So tell me for this one. So 60 minus of T1. So T1 is nothing but 60 minus of 10 into A1 value is how much? 16 upon 5. So this is once, this is twice, 16 to 32. Yes, T1 is equals to 28 Newton. सभी कितना है? Okay, very good, excellent. And T2? So T2 equation is what? T2 minus or which is equals to 40 plus of 5 into A2 is how much? 8 upon 5. Yes, T2 is also 48 Newton. Yes, very good. Okay. Now listen to me. Question number B from the same diagram. Question number B from the same diagram. If you are having one string like this now. Yes or no? If this one is being cut, now tell me the value of acceleration of each block as well as the tension. Okay, come on, try this. Shall I? Okay, सुनो अभी देखते हैं. Let me check your answers first. So this one is your 37, this one is your how much? 53, and over here is one block, and this one is being tied over here on a fixed pulley. There is one mass over here again pulley, and over here is one again pulley. This one is being connected with one more mass. Mass bolo re iska 10 kg, mass of this one 5 kg, mass of this one 5 kg. How much is the force acting in this one? 40 Newton. How much is the over here? Okay, 60 Newton. So T1 इसको नाम था, T1 is this one. This one is your T1. So T1 कितना मिला था before cutting situation, and we got how much? 28 Newton. And this one is your T2. T2 कितना मिला था? 48 Newton. And acceleration before cutting accelerations are what? How much? This one? This one is A2 na? Or that one is A2? This one is A2. So this one is going before cutting situation. A2 is equals to 8 upon 5 meter per square second, and this one 16. Okay, so this one is going with what? 16 upon 5 meter per square second. Anything else we need? No, no. Okay, now what we have cut? We have cut this one. अरे सर अबे इधर से काटूं या इधर से काटूं, रस्सी तो एक ही काट रहा हूं ना. ओके, सो नाउ लिसन टू मी. Question is what? Find out the acceleration of each block after cutting of this string. String only. So if we cut this string, what will be the acceleration of this one? Obviously, if we cut this 48 becomes now 0. This one will be gone. So if this one will be gone, then only 40 Newton is acting in the downward direction, and this one is 5 kg. So acceleration of this one is A. So acceleration of A is nothing but 40 upon 5, that is nothing but 8 meter per square second. ये तो easy है, छोड़ दो इसको. Okay, now, okay, sorry. Thank you. Now, okay, और कुछ छूट गया? नहीं ना? Okay, now, so block B, this is your block B, and question is after cutting, obviously this becomes, oh, no tension will be acting on this one, but T1 28. Why? Because there is a spring. Are we doing anything with this spring? We are not doing, or we are not cutting that spring. If we are not cutting that spring, beta, then the tension in that spring changes. It won't changes. Are yes or no? Just after cutting, in the fraction of seconds, nothing will be happening to that spring. Are yes or no? The force is being stored in that spring only. Okay, so this T1, that is what over here is T1, over here is T1. That means over here is nothing but 2T1. Are yes or no? And T1 we got 28. 28. This 28, and that means on that 5 kg, that is nothing but 2T1 will not make any difference. So to calculate the acceleration of this block B, so for block B, I am writing the equation 2T1 is nothing but 5 times of A2. Okay, but this time the A2 is not what? 8 by 5. Okay, let's say after cutting that becomes with A. Okay, so this is just after cutting situation. Now it won't be going with the same acceleration. This went with what? 8 meter per square second. Now we need to calculate this acceleration. I got my point. Let's say this one is going in this direction by A. I got my point. Okay, if that one is going by the A and 2T1, T1 remains same, I told you, na? Why? Because we are not doing anything with that spring. So T1 never changes here. Are yes or no? So 2T1, that means 2 into T1 is what? 28, that is what? 56, which is equals to A. Or how much? 11.2 meter per square second. Kiska hai re? Okay, very good. So this acceleration of what? B. So this is the acceleration of what? B. And those who have taken this because of that spring restored its force. Yes or no? And the next, what is the acceleration of C? Initially, it is going with what? 16 meter per square second. But after cutting, that one will be going or not going? It won't. Same situation like this. Consider here is one spring and here is one block, and this one is connected to this one. If I cut this spring, this one will be going in the downward direction, but the acceleration of this, let's say this one is your A, so acceleration of A becomes what? 0. Are yes or no? Same situation like this. So acceleration of C is what? 0. Are you got my point? Okay. Same diagram again. Question number 3. अबे किसी को कोई डाउट है क्या इसमें? नहीं है ना? Okay. So now the third question on this same diagram. If I replace this spring, if I replace that spring with string, okay, then what will be the acceleration and the tension if again this one is being cut? Okay, same diagram, same string is being cut, but now this spring is being replaced by string. Okay, find out the acceleration of block C, block B and block A. Obviously block A again will be going with what? 8 meter per square second. So no need to calculate A, just calculate for B and C and tension in that. Okay, come on. अभी आ गया ना तुम लोगों का आंसर? अभी देखो वही जो मैं बोल रहा हूँ ना, अभी सुनो ध्यान से. Okay, now so like, okay, now 60 Newton is acting in the direction, let's say T. Over here this one is accelerating with, let's say, A and A1, and this one is accelerating in this direction by A2. Are yes or no? Still you have to apply beta constraint. What is the relation we got in with the constraint? A1 is nothing but 2 times of A2 ना. ये तो constraint से मिला है. Okay, you have to apply this. Are got my point? Without applying the constraint, you cannot reach to the answer. Are got my point? Okay. Now the situation is, if we cut this one, what will be the tension and what are the acceleration? Okay, if I cut this one, is there any force over here? No force. Tell me the equation. So 2T is equals to 5A2. That will be the equation for block B. ये तो change नहीं होगा. Okay ना? Then what will be the acceleration of this one? Obviously that one will be accelerating with different value. Those who are thinking that this one and this one will be accelerating with same, तो constraint का पढ़ने का फायदा ही क्या हुआ बेटा इतना दिन? I got my point. So if I want to write the equation for C on a block C, then it is going in the downward direction. So 60 minus of T, that is nothing but 10 of A1. I got my point. Okay, now you have to substitute the value. Then I can write this equation as 60 minus of this is nothing but 20 A2. अरे आया क्या? Now substitute, or this can be written as like this. इसको करो 4 into 5 A2. Substitute 5 A2 value is 2T. ऐसा तो करो. Or either substitute T is equals to 5A by 2. Or either substitute like this. So what? ऐसा भी करो. You will be reaching to the same values. So let me substitute 5A2 is equals to 2A. That means this equation can be written as 60 minus of T is nothing but 4 into 5A2. Okay, what is the value of 5A2? 2T. Substitute over there. 2T into this 4, 80. And T comes over here, 90. So T value is nothing but 60 upon 9. And this is nothing but 3's. This becomes what? 20. So tension is nothing but 20 upon 3 Newton. I got my point. Substitute T value in any equation or in both equation, you will be getting A1 and A2. So substitute over here. So 2T, which is equals to 5A2. Yes or no? And 2 into T, that is 40 upon 3. So 40 upon 3, which is equals to 5A2. This is 1, this is 8. So acceleration of A2 is nothing but 8 upon 3 meter per square second. I got my point. Similarly, substitute T value in this equation, you will be getting what? A1. And that is nothing but what? 60 minus of 10 into A1. A1 कितना है रे? Sorry, A1 we need to calculate ना. So 60 minus of 20 upon 3, which is equals to 10A1, and this becomes 180. 180 minus of 20, that is what? 160 upon 3. So 160 upon 3, that is equals to 10A1. This 0 get cancelled. So A1 is nothing but 16 upon 3 meter per square second. I got my point. So please focus on the constraint. Don't forget to apply the constraint. आए बात समझ में? Okay, enough ना? क्या और टाइम पास करेंगे? Enough? Okay, come on, write down.